Welcome to Math 105, where we're talking about our probability lab. So this is another Excel file that we're going to be completing together and having you guys answer a number of questions. Now, if you're doing the online course, make sure you're watching or you've understood Chapter 7 before moving on to this lab. This lab is actually really good after covering Chapter 7.2 and 7.3 to get that good foundational understanding. So first thing we're going to do is to create a title page, which if you wanted to just copy and paste the one that we did from your simple interest Excel sheet, that is completely fine. But if you're making a new one, just make sure you have the title of the lab. In our case, it's going to be called the probability lab. Make sure you have your first and last name, the date, and Math 105. Again, make sure you make it look nice and pretty. I don't want things cut off. I need to make sure you have your name in there. A little bit of effort goes a long way. So now let's go to problem 1. We can title this as your title page in case we look back later. We'll label this as problem 1. Again, I'm going to zoom in a bit. Come on. Okay. So up and over. So we're going to follow this template. So it says, in this problem, you'll use Excel to construct a probability distribution for the sum of two dice. So enter in the following sheet. So we're going to write problem 1. And I'll make sure that everything's nice and fixed. Notice that in column G, it has name, course, that stuff. We don't need that because you already have your title page. So please ignore that. So it looks like in A6 to A11, we're going to, let's see, where did it go? Merge and center right here. So merge and center. You'll notice that when I type in die 2, that's going to stay on the bottom. So I want to make sure everything is centered and then centered in the middle of our merging. So then it also looks like we have the number 1, 2, 3, 4, 5, 6 for the 6 sides of the dice. Again, I want to make sure everything's nice and centered. I want to make sure it looks nice and professional. We also have going across the same numbers, 3, 4, 5, 6. Again, merge and not merge and center, just center. But then above this part, we do have your dice. So C4 to H4, we're going to merge and center. Again, making sure everything is nice and aligned. This will be die 1. Oops. 1. There we go. All right, so we're also going to fill out this part. So in 13, we have sum, we have number of ways, we have probability. Now, before I get too technical, after I kind of just format some things, I want to get a clear divide. So notice that everything here is boxed in. So we're going to go up to the borders and we're going to click all borders. And you can see what that might look like on the side over here. And that'll just fill it out so that we can actually go back and reference this. And it looks very neat and professional and easy to read. Now, because we're talking about the sum of two dice, right? If we roll a 1 first and a 1 as well, then the sum of the dice is 2. And then a 1 and a 2 will create 3 and then 4. So with that idea in mind, can you fill out the remainder of the chart? We have 5, 6, 7. Now, a couple tricks to the trade as well. You could say equals this plus 1, right? 2 plus 1 is 3. And then we can practice something called the drag, where we're waiting for this little formula to have a little plus sign and it's black. And then we can drag it across. So 1 plus 6 is 7, so that works. And then again, if we wanted to do that one more time, I'll show you it's equal to, and it doesn't matter which one you do. Maybe I try to drag it down. This plus 1. Just the one above it plus 1 and then drag. You could also, now that you have a few here, write 3, 4, maybe it'll work with here as you're going through. No, that's not working. Normally it works. I can also just hand type 5, 6, oh, 5, 6, 7, 8, 9. 6, 7, 8, 9, 10, 7, 8, 9, 10, 11. You always want to make sure that everything looks good. Let's see, 8, 9, 10, 11, and 12. So as I'm going through, I just want to double check everything is correct. Going across. Now, if your numbers are incorrect, the next part will not be accurate and will result in a loss of points. One thing you can do as you format, you can put in some color if you'd like, maybe borders, whatever you think would look professional, sort of some clear definition in there. I might do an outside border here, outside border. I don't know, something that makes it look nice. I did center these as well, but let's continue. So we have this template. We've made it look pretty professional and neat. And it says, now you will need to count how many of each sum are possible and then find the probability. Use a formula to do this by doing the following. So it says in cell B14, so B14, actually that should say, oh, so sorry, before we do that, it says the sum. Now what that means is that what are the different sums available, right? So the sum of 2 dice, right? 1 and a 1 can make a 2. And then a 1 and a 2 make a 3. And a 4 and a 5. And we're going to keep going all the way until we get to your highest sum of 12. So again, we can either type or we can practice highlighting and dragging now that it has enough. You'll see as I'm going through, it drags down. So the sum, we're going to enter in all of the sums that you're seeing here, only recorded once. Now the number of ways just means, well, how many different ways can we calculate, or how many different options or ways can we get a sum of 2? Well, looking at our chart, right, a 1 and a 1 can get us to a 2. So there's only one way that that's possible. And then if we're looking to get a 3, well, there's 3 ways, right? Now what I'm looking for, I know I can count here, but it's a lot of work and I want to make Excel do the work. So instead, in cell B14, we're going to enter in this following formula. It says equal count if, doesn't matter if it's capitalized, but it says range. So where do you want our range? Like, where do you want me to count? Well, I'm going to be counting within this block of cells from C6 to CH. Now, or C6 to H11. Now, if you wanted to do it here as well, you can type it in. Now, notice the discrepancy here. Ours has a $sign. This one does not. And I'm going to show you what the big difference is in a moment. So I'm going to make a mistake on purpose. Now, once I type that in, I'm going to hit comma and then A14. It just says, of this range, what do you want me to count? Well, I want to count in here how many times a 2 pops up. Close your parentheses and hit enter. So as we can clearly see, there's only one way to get a 2. Now it says, now it says drag this formula down to cell B15. Okay, so if I drag this down to B15, right, notice that it says, okay, the number of ways to calculate a 3 is going to be 1. Is that possible up here? Definitely not. Now let's say we didn't take a close enough look, we didn't know, and instead I'm just dragging and going. Something should tip you off at this point that our formula is wrong. Now, when I double click, notice that when I double click, it has moved this range down by 1. This part is good because it is telling us the sum of 3, how much 3s do I want to cancel? And then again here, and notice that it's moving down. So anytime I don't have the $signs around here, it's not going to lock in this area. So anytime you want to lock in a cell and not have it move, we're going to put $signs around your letter. So just as you have it here on the right of your screen, should be our equation. So now I'm going to hit enter. And then we're going to try dragging that one more time. Now that the correct formula is in there, wait till your plus sign is black and then drag down. Double click, make sure everything looks like it's correct. So we're hoping that this whole thing in blue right here is still correct. And we are moving down to the sum of 3, which should be 2 ways. Sum of 4, 3 ways, 1, 2, 3, that's perfect. Now let's move on to the probability. Notice that I'm centering as I'm going. I want to make it look nice and professional. It says now in C14, enter the formula for probability. Well, what is the formula for probability, right? Well, it's usually, it's the, and you do not need to write this, but it's the total, so the number of ways the event can happen divided by the total number of ways, right? So what that means is that I'm going to hit equals. Well, the number of ways the sum of 2 can happen is 1 way, but 1 way out of how many, right? How many ways could we have had it here, right? 1, 2, 3, 4, 5, 6, and you could calculate that up, but it's really over 36. Now I'm going to get rid of this since we don't really need this description anymore. Again, we don't need it to have so many decimal places, at most 4, at least 2. Okay, so I might extend out to 4 unless it says specifically format cells C14 to C24 to 1 decimal place. Okay, so it wants specifically 1 decimal place. Oh, that's so strange. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. All right, let's drag down and go. Actually, let's change that 1 decimal place. Let's do 2 decimal places. Yeah, that looks fine. Okay. Oh, I'm so sorry. It says 8% with 1 decimal place. There we go. So let's highlight here. I can't read clearly. Let's highlight here and go up to general. And then we're going to change this to have a percentage here. Then if you wanted, you can go down to 1. Now, I'm not going to take off points if you have 1 or 2 decimal places. I'm actually a bigger fan of the 2, so you can change that here if you would like. I'm going to keep mine as 2. And again, I'm going to center it. So this is our setup, and now we're going to be answering a few questions. So in our text box, it says, A, what is the probability that the sum of the dice is 5? B, what is the probability that the sum of the dice is 10 or more? I want to say there was a third. C, what is the probability that the sum of the dice is less than 6? And D, create your own probability question and answer it. Do not do a simple one such as A. So what I mean by that, it has to have some sort of range. You can just get as creative as possible. Again, you don't need to calculate anything. You might need to do a small calculation here, but again, use Excel, not your calculator. So you can put B's answer here, C answer here, D's answer here, and then put it into sentences. So make sure these are college level sentences. Okay, I want to see some sort of description on your Excel lab. So on your answers. All right. As far as formatting goes, I might choose to make this bold. I might also choose to make this Times New Romans. I just think it looks a lot cleaner. Okay. All right. So pause the video, see if you can answer those questions. And then when you're ready, let's move on. Oh, actually, so sorry, we have to make a histogram. I'm moving too quickly. So it says now construct a histogram of the probability distribution. It says highlight cells C14 and C24. So C14, and you can, if you wanted to, highlight the probability value as well. It won't make much of a difference. And then we're going to, we can, if we want to as well, hit the control button, or depending on if you have a Mac, I think the equivalent of control is what, like command. So you're gonna highlight all of this and then hold down the control or command button and then highlight this next one. Then we're gonna go ahead and insert. Again, you can do recommended charts if you want to. We're gonna be selecting this column chart. So click OK. Let me zoom out just a little bit. I'm gonna center it under here. Now probability, well, what, I know it is probability, but what type of probability are we talking about? What is our scenario? So reread problem 1, and perhaps you create a better title. I want to know when I look at this graph, what does it actually mean in the context of the problem? Okay. Which means we're going to add chart elements, either adding your axis from here. Again, I want to know, what does 2, 3, 4, 5, 6, 7, 12 mean? Create a better title. Let's get rid of that for a second. What do these values mean? Create a better title. Now what we're going to do is actually make a histogram. So once we have your titles all aligned, we can go ahead and change your colors if you'd like to, but we are going to kind of click out here for a second. Notice that it has these values highlighted. So we're going to go ahead and double click our bars. I just hit double left click. I think on Mac sometimes I hit a right click as well. But anywhere it says format data series, sometimes you can get it up here as well. It just takes a minute to find. Sometimes it's like select data, it's got to be somewhere up here. Now we're going to try to get this gap width all the way down to 0. And again, let's change our colors. Mine is a little dark and I want to make sure that I can clearly see our divide in the line. So maybe I make it a little bit lighter. Borders, maybe a solid line. And I want to make sure that I can see clearly what we're looking at. So then when I hit out, I can clearly see these values. Now, if I wanted, I can also put data labels on here and you can clearly have these values up here. That would just like add more context to our problem. It would be better looking. Again, if you don't have that, not a huge deal. You can also find it up here in chart elements with the data labels, and you can you can change where they're found. Perhaps maybe I like that one. So something along those lines. All right, let's look at problem 2. Okay, let's increase that just a little bit. All right, so it's problem 2. In this problem, you will use Excel to now simulate rolling a dice 100 times and constructing a relative frequency distribution. So problem 1 is actually what we did in chapter 7.3, where you talked about these are actually modeled or accurate or real probability. And now in problem 2, we're doing a simulation. So this is an experiment. So it's an experimental probability. Your relative frequency, there you go, relative frequency here. We're going to be pretending like we've actually rolled this dice. So we're going to set up the same thing right here. So we have roll number, you have your dice, 1, I2, and then your sum. Over here, we're gonna do sum, frequency, relative frequency. Don't worry about your name. We already did that from the title sheet. All right, so one other thing that we're gonna fill out, 1, 2, 3, 4. I'm going to highlight and drag down here. And I may as well center everything. So if I want everything centered, I'm just gonna hit this triangle here and then center everything. I may as well put everything in Times New Romans while it's highlighted. I might want to orient this to have some bold characters. Notice here that things are being cut off, so maybe I double click, get things pretty like to shift over. So I like this look. It gives me a good start to everything. Now let's do this part. So number of roles. So from here, right, it says we're gonna have in 4, we're gonna have 1. And then it says equals A4 plus 1 equals A4. You just have to click, or you can type plus 1. Now what that's gonna do is just take this value and add 1 more to it to make 2. And instead of doing that multiple times, because we're trying to simulate a dice roll, so instead of doing 1, 2, 3, 4, 5, 6, 7, right? Instead of doing that all the way down to 100, what we can do is now we're going to wait till it turns black, and then we're going to drag all the way down to 103. 103 being 100 rolls. I didn't just come up with that. It does tell us over here to drag it down to 103 so that the last value is 100. So then in cell B4 and cell C4, enter the following formula. So in B4 and C4, we're going to be doing this part here where it says rand between. So we have equals rand between. Now this is going to randomize the numbers. Notice when you, hopefully you've been seeing some of the stuff we've been doing, where we hit equals and some of these specified values, it'll tell you what it needs. Bottom, your bottom number to randomize all the way between numbers to your top 6. So we're going to randomize all of the numbers from 1 to 6. And again, we are going to drag all the way down. Now, I don't know if you noticed, but my first time I did it, my first number was 5 and now it's 4. It's okay that each time your number is going to change. That happens quite frequently. Every time you hit enter, it will do it, and that is okay. Notice again, I hit enter, it changed. Again, I'm going to say that one more time. It's okay if your number changes. Okay, so those are our 2 dice being simulated, rolled 100 times. Now we want to figure out your sum. So it says enter an appropriate formula in cell D4 to add to the values of the 2 dice. So we want to know, well, the sum of what? Well, the sum of your 2 dice. So we're going to hit equals, and I want to add this dice here to this dice here. And again, hit enter. Notice that it was 2 and a 5, and now it's 3 and a 6. That is okay. They're going to change. You just need your formula once, and then we're going to drag all the way down. There you go. And you can double click and make sure that it's doing what it needs to be doing. You can also see that from up here as well. So these are, this part is right here, your experiment. So now, taking your experiment, let's figure out the relative frequency, or the frequency of these happening, right? So the sum, so how many times did the sum of 2 happen? Well, if I'm looking here right now, I don't see a 2 and I would have to scroll down. I'm still not seeing a 2, right? But we have a whole 100. Oh, I just saw it and I missed it, right? So I have 1, right? And I would have to do that all 100 times, right? So instead, let's make Excel do the work. So let's go in cell G4. We're going to enter in the formula equals count if. So we're going to count if, again, the range. Where do we want us to start counting, right? well, I'm going to calculate, or I want to count all of these values and figure out, well, of these values, what do I specifically want to count? What number do I want to count? So your range is always the values that we're looking at. And again, we talked about last time trying to lock in these cells so they don't move. So we're going to put in a $sign around your letters. Now, what number do we want to start with? Well, we want to start with the sum of the dice is 2. Now, that would be found in F4. And you'll notice here it says F4, close parentheses. And when I double click, it's just saying that, again, this number is going to change as we're going along, right? So it's going to be 4. And let's drag and drop. Now notice that your numbers keep changing. Again, totally okay. Now kind of basic, before we do anything else, kind of look at your numbers, see how they're changing a little bit, right? We go from 0, 4, 10, 8, 17, 19, 17, 11, 7, 6, 1. What is happening, right? Think about what we just did in problem 1, right? And what might be similar and what might be the difference. So it says, enter an appropriate formula for the cell in H4 to find the relative frequency and drag it down. So the relative frequency, right, is equal to the frequency of which the sum of 2 happened, divided by your total. Well, what is our total? Well, your total is the number of rolls. We had no rolls or no sum of 2 happen in 100 rolls. We're going to drag that all the way down. Let's see, it does say format your cells as a percent. So let's change this value to a percent. And we can change this to 1 decimal place or 0 because these are all as a whole number. So it says in a text box. So let's go ahead and insert a text box. So I'll insert one right here. Okay. How do your values in your relative frequency distribution compare the values in the probability distribution in sheet 1? That's just problem 1. Is this what you expect? I need college level sentences. I need you to flush it out. I don't want just a small 2-word, like 2-sentence. I need a really big description. That's what I'm looking for you to gain all of those points. If you simulated 1,000 rolls of 2 dice, what would you expect to happen to the values in the relative frequency distribution? Now, to help you guys out with this one, or with these two, I would say compare their graphs. So what we're going to be doing now is getting the same type of graph, but on this page. And I'm going to even give you a hint. So when answering, look at their graphs and compare. Also, look at the beginning notes of chapter 7.3. Compare to problem 1 and problem 2. Okay, so that's kind of your hint, okay? Now let's construct a relative frequency distribution in the same way that you constructed the histogram. So we are going to go above here. We're going to be looking at the relative frequency here. So we're going to highlight, hold down your control button or command, and again, highlight the sum. Let's insert a recommended graph. Let's do this one. I'm going to zoom out just a little bit. I'm going to just put it down here for now. Let's add some chart titles. Again, relative frequency, but of what? Create a better title. Again here, create a better title. Your title up here should not be one word. Your title here can be one word. Same thing with here, but the more description, the better. It doesn't have to be the longest description, but something that when you go to look at this chart, you can clearly tell what is happening. All right, now let's make it into a histogram. So let's double click here. Oops. Gap width of 0. Let's change your color a little bit to something a little bit lighter. Again, you can still have fun with it. If you wanted to change your color a little bit and go from there, perfectly fine. Let's also maybe add your labels. You can also go to orient it just a little bit so that maybe they're inside again, right? Again, each time you go to manipulate these values, let's see, is it going to happen again? Yeah, so notice that each time you go to make a change, it's going to come up with a different type of graph. But definitely make comparisons between this graph and this graph. What's the difference between overall problem 1 and problem 2? All right, last problem. So this is now the birthday problem. Make sure you are saving as you go. We don't want to lose your work. So it says there are n people in a room. Find the probability that there is at least one pair who have the same birthday. Okay, assume that all birthdays are equally likely, disregarding leap years. Okay, so we're going to build this template. We have problem 3. So sorry for the background noise. We have sample size. And we have number of arrangements of n birthdays. Number of ways to have no matching birthdays. Let's see, probability of no matching birthdays. And the probability of at least one matching birthday. So let's expand these. Okay, it's telling us that our sample size here for today is 30. Okay, now we can go above or below 30 when we're going to answer our question. So it's just starting us off with 30 people. Okay, that can change. So it says equal 365 for the number of days in your year, disregarding leap years, raised to the B3. So B3 is here, right? Your sample size can change, your days cannot. Think about what we did in, I want to say that was chapter 6.3 and again in 6.4 or 7.4, where we said, well, the number of options doesn't change, but the number of questions can. Same idea here. The number of days cannot change, the number of people can. Okay. Now we'll talk about this number in a moment. Let's keep going. Permutations equals permutation or pure permute. This is just the stuff that we do on your calculator, right? 10, choose 4, right? But this time our order matters. So permutation 365, right? It says number, comma, the chosen number. Of the 365, we're going to choose 30 people. Again, we're going to be selecting B3. And this is all found on your template. Now this is equal to B5 divided by B4. Now the reason why we're dividing is that if this is the number of different ways we can arrange 365 birthdays given 30 people, so this is the total, and then this is the number of ways we can only have no matching birthdays. So the probability here is the probability of no matching birthdays. Again, we don't need this number to be super large. This can be put into either as a percent or as a decimal place. It doesn't quite matter. Now these numbers, notice that it has E plus 76. This is in scientific notation. It just means that this value is very, 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 very large. We just have to move this decimal place 76 times. Now we have the probability of at least one matching birthday. So what we did is to find no matching birthdays, but keep in mind ours is to get at least one pair. So only one person has to match. So the opposite right now is what we have, no matches. So we're going to hit equals 1 minus the above. We're going to negate the above. So notice we have, in our case, in a sample size of 30 people, there's going to be the probability of at least matching, one matching birthday is about 70.63 or 71%. Now it says experiment with changing the values in B3. So in here we can change your values, and notice if you did it correctly, it's going to be changing these values here. So 2 matching birthdays, or sorry, 32 people will get us to this amount, and we can keep changing and going, right? So I'll just revert it back. You can go higher or lower than 30 to notice that change. So now in a text box. Okay, what is the smallest sample size? That sample size is in 30, so change this value, okay? Change B3. That will give you a probability of at least one matching birthday over 50%. Use trial and error. So what I mean by that, right? Right now at 30 people, I have 70.63, so 70.63%. I want it to get over 50, but I want to get as small as possible. So if I did 29, that does go down, and I'm getting closer to that 50%, right? I want to be over 50, but I still want the smallest sample size. So you're going to be changing this B. What is the smallest sample size? Again, changing B3, that will give you a probability of at least one matching birthday over 90%. And again, use trial and error. So if we change this back to maybe we do 35, well, that certainly is on our way to getting 90, right? So just keep messing with it, figure out what's the smallest amount in B3 that we get to meet these satisfaction. All right, so now this one is just extra credit. So in theory, big emphasis on the theory. What is the largest group of people you could have with no matching birthdays? Your birthdays cannot repeat. No trial and error. Think logically. So this is going to be extra credit. It's not going to be graded. It's easier than you think. So big emphasis in theory. If you were to stuff a whole bunch of people in a room, right? What is the largest number of people you can have without any repeating birthdays? Again, no trial and error. You're not going to be using Excel. You're just thinking about it logically. All right, make sure you're saving as you go. I'll show you kind of, again, one more time how to print. Maybe I widen these margins. Want to make sure everything's fitting here. Maybe I make sure that this is in bold. It looks nice and neat. This one, I think I will have some cutoffs, and notice that I am cut off here. By no means do I need all 100 here to show, but what I do need is for the sum and relative frequency and these two values to come up. So perhaps this is a great way to work on clicking and getting this to be a print preview. You can print your graph all in one. Same thing here. Let's see. Sometimes it works, sometimes it doesn't. No, so it won't actually work with this one, but perhaps you widen your margins a little bit, narrow your margins. So that does a little bit, but maybe I don't want our graph to be too itty bitty, so I might throw my graph over here. I might bring this to go down a little bit, squeeze it in there a little bit, print that off, and then print this off separately. All right, same thing here. Let's see what's cut off. There is a little bit of cutoff. Again, if I see anything cut off, I will take off points. It's about 2 points. So I just need to squeeze that in over here, maybe a little further down. So that looks okay. Again, maybe you change your margins just a little bit. Orientation, let's just go back to portrait. Again, one more time. That looks really great. And again, here, I know everything's gonna fit. Make it look nice and professional. All right, don't forget to save and then submit your Excel file to Canvas. It does have to be the Excel. Do not just send me an email. I need it to be in Canvas. And then do not forget to print it off and hand it to me in class for those who are taking it in person.